happy to be here to share with you some hints about topography and tomography for keratoconus detection. So it's been a long time from we know keratoconus, and we moved from macroscopic qualitative to what's just been presented, which is computer-assisted specular video topography, which gives you information about anterior curvature of the cornea. Tomography, which was introduced in the mid-90s with the Orb scan technology, is addressing the issue of showing the shape of the cornea. It's more direct, and shape is really the kind of a coordinates in space of the anterior and also the posterior surface. If you have the shape of the cornea, the problem is to show it to the doctor because the differences are very small compared to the macroscopic shape of the cornea. This is why the best fit sphere, BFS, is always used to show elevation. Sometimes you can use other surfaces, but once you found the most closest fitting surface, you can plot an elevation map showing above in warm colors and what's below the sphere in blue colors. So always remember that what you see is very tiny. The cornea can be thought of a 1 centimeter organ, so 10,000 microns, but the steps usually on elevation topography are about 5 to 10 microns. Sometimes it's obvious at the slit lamp that you have keratoconus, and on elevation, a keratoconus is an extreme departure from the best fit sphere shape. Hence, you have not so many green points, but more or less dark green, dark blue or dark red. Tomography is also performed with Scheimpflug technology like the Galilei or the Pentacam, but they're all based on the same principle, which is you slit scan or you Scheimpflug scan the cornea and then you reconstruct the surface in 3 dimensions. The main elevation and tomography instruments today are the Orb scans, the Pentacam, the Galilei, and the TMS5 from Tomei. They provide various information. Interestingly, 3 of those instruments, they also have Placido technology embedded, and they have various indices for keratoconus detection. Interestingly, also, the Galilei only base its analysis on Placido indices, same as Tomei, whereas Pentacam and Orb scan now have elevation-derived indices. So for the Orb scan, what you see usually on a map is elevation anteriorly, elevation posteriorly, the best fit sphere ready, and you have also a Placido map, pachymetry, and some data in the middle. With the Pentacam, you have also an axial curvature map, which is calculated from elevation, a pachymetry map, and an elevation map, and also curves which are showing you how the cornea thins or thickens from center to the periphery. And from this, what you have to do is detect with tomography keratoconus in its earliest stage, and this is a classic depiction of what you would find in those elevation maps. You would find decentered elevation, increased posterior float, and thinnest point vertical eccentricity compared to normal cases. Keratoconus, again, is a deformation of the cornea which makes surfaces more aspheric, more toric, more irregular. And if we try to plot what's going to be happening in a cornea like this, interestingly also, and we publish this in Cornea, when you look at what happens on the posterior surface when it becomes more aspheric, which is the Q value becoming more prolate, you see that the red in the middle goes way higher to warm colors than if you address less steep surfaces, such as the interior surfaces. In other words, from the same degree of negative asphericity, the posterior surface, because it's steeper centrally, will show more red colors and more quickly than anterior surface. And this has given the clinician the impression that posterior surface carries some very early information about keratoconus detection. And this is also giving rise to algorithms such as the BAD display, which is based on the use on a surface of elevation to plot the elevation of the cornea, which excludes the central point in the 3 millimeter. So if you have a 3.5 exclusion for the points of the cornea, you will have a flatter best fit sphere, which will increase the central excessive elevation. The little video on the upper right is showing you that What's important, again, is the sphere or the surface you use to plot the same surface, and depending on what you use, you can have a very different map. Also, the cornea is not a plastic organ. It has a epithelial layer, which may play a very important role to maybe smooth or mask early changes of the corneal wall. And again, if the cornea becomes distorted, aspheric, more prolate anteriorly and posteriorly, what may happen with time is that anteriorly the epithelium may remodel itself to make the cornea less prolate. Hence, you would not see dramatic changes anteriorly, and you would see them more posteriorly, because posteriorly there's no epithelium to compensate for those changes. So epithelial compensation has been demonstrated in vivo today using OCT, which will be the next talk. And you can see an epithelial map here with less epithelial thickness in the center in comparison to the periphery, probably to make the corneal surface a bit more regular. So elevation, in my mind, is very interesting, but it's not as sensitive than specular topography for some reasons. And sometimes interesting, you have people coming for refractive surgery evaluation, and the placido-derived indices, such as with the OPD scan here, are showing keratoconus suspicion. And we developed a score based on placido analysis for the OPD scan, which again confirms that because the value is more than 0, there's a problem there. But when you look at the ORB scan map, at the biomechanics, everything looks normal in terms of elevation and thickness. This is the ORB scan right eye, this is the ORB scan left eye. Only you have this inferior stiffening, which is odd, but you can do a pentacam, you can do a tomographic analysis, and yet there's no real abnormality there. And so, because there's this inferior stiffening, you're like, what do I do? I would do probably LASIK, but if I wouldn't do LASIK, it's not because of ectasia, it's because of ocular surface, because here, placido is sensitive to some SPK, which is due to some eyeliner that the patient would use daily, which would cause surface irregularities and SPK. And this SPK is explaining the kind of artifact curvature steepening there. But this is not keratoconus here again. And you know it because of elevation. And the final problem with those analyses is that there is always an overlap. So it's difficult to come with a magic index to detect keratoconus. For example, if you have form first keratoconus and you analyze their irregularity in the 3 millimeter in terms of elevation, or if you look at how the thinnest point goes down vertically, it's very difficult to separate those two groups because you can see that the values are very overlapping themselves. But the solution maybe statistically is to use many variables, and this is based on what we call the linear analysis, the discriminant regression analysis, which may help you to derive scores which comprise more than one indices, and this will help you to get better separation, reduce the number of false negative, and have better ROC curve. And a few years ago, we took two groups, one group of normal patients, one group of form first keratoconus patients, and we looked at how anterior curvature alone could separate those two groups. And you can see the ROC curve, the higher the better, is not that very good. So anterior curvature is not very good in itself. Then we looked at posterior curvature. It's just slightly better, but it's not really what we would use statistically to be sure of what we're doing. If you go at pachymetry in our tomography, you see that it's probably a significant step ahead toward better separation between normals and form first. But the best separation was, of course, achieved when we combined linearly all these indices together. And you could see now we had acceptable separation with good sensitivity and specificity between those groups, and it's published in IOVAs in 2010. So this has given the birth of a new analyzer for the ORB scan, which is named the SCORE, and it's comprising placido, tomography, elevation, information, and when the score is positive, we probably face a very cornea very similar to a form first. So we do PRK for low scores, but we don't do LASIK for those scores, and we can also use It's been published, as I said, and we use those maps to investigate also keratoconus progression, but that's my second talk. So I would finish just with one example of a case, which is my case in 2005, which I saw for LASIK or PRK, and everything looked normal to me. Placido was normal. You can see indices there. And elevation, despite a posterior float, which is quite red, would not really alert me. I did LASIK, and 7 years later got ectasia on the left eye. So you may think it was a high myopic error, but it was not. It was a -3 correction. And I did OCT, and the posterior residual bed thickness was more than 300 micron in the left eye, which got ectasia. So we did a score retrospectively. We took the pre-op maps, and we were surprised to see that the score would have predicted that ectasia with a slight 0.2 error, whereas in the other eye it was negative. So in conclusion, elevation and tomography is certainly something you cannot skip today for your evaluation, but keep also your Placido maps to increase again your sensitivity and specificity. Thank you very much.